Hello, everyone. My name is Alexandros Patsanis. I work in DNV, and I'm going to talk today about the AI in DNV. And I have 3 points: simulations, healthcare, and maritime. And I will explain why I have those 3 there. So a little about me. I have a bachelor in informatics and communication engineering. I have a master in computer science that I did in Uppsala University in Sweden. And I have a PhD in medical technology that was in NTNU in Trondheim, and that was for deep generative models for prostate cancer detection. And I joined DNV in 2023 as a research trainee. I had 2 years, very good 2 years, and now I'm a data scientist in the maritime section. So today I'm going to show you a video about DNV and some other information about the purpose, if you don't know, and the areas that DNV involves. And then I'm going to talk about AI in simulation technologies, AI in healthcare, and AI in maritime. And those are 3 of the rotations that I had in those groups. So let's start with the video. This is a video from last year, 2024, where DNV had the 160th anniversary.
This year, DNV marks its 160th anniversary. Through all these years, we have built trust and confidence between parties. Whether it's assessing safety at sea, optimizing renewable energy, certifying supply chains, improving patient care, or managing cyber risks, we have made sure that things work in a safe, sustainable, and reliable way. Companies will succeed only if their work is underpinned by trust. For that, they need an impartial and clear voice they can rely on. We are 15,000 people all over the world, providing facts and independent expertise to be that trusted voice, today and for the next 160 years.
So that was a short introduction about DNV. Can I just ask who of you actually knows DNV and what DNV does? Okay, that's good. And at least I had this video. So we're around 50,000 people. We have around more than 100,000 customers. We're operating in more than 100 countries. And importantly, we have 5% of the revenue goes to the GRD, which is the research and development. And the 2 points that I have in the presentation for the simulation technologies and the healthcare, it is with GRD. And the other one is the business area. That's why I have 3 different there. So the purpose of DNV is to safeguard life, property, and the environment. And then we have different areas of expertise. We have maritime. Most of the people knows the DNV in maritime. However, we have a lot of going in energy, aquaculture, cybersecurity, health, digitalization, and AI, and much more. However, I could not put everything in this presentation. I focus on those that I had experience with. So let's start with the first one, which is the simulation technology in the research and development. And this is a group in Trondheim. And this is the team there. And when I was there, I was a trainee, and there were also some other people, and I had my own projects there. But before I show you what project I had, I will just explain what the team does. So I would like to start with what the industry needs, and then I will explain you also how AI comes in this project. So the industry needs to build scalable and efficient digital twin simulation of complex integrated systems. You can think them as the whole vessel, for instance, a vessel or parts of it. And then this is important because we can reuse those simulation models in collaboration with stakeholders. Because sometimes it's very important to not sell the IP, the intellectual property of those models. However, we want to see if those can be trusted and if we can assure those. So the last 2 points here, I'm not going to go deeply on that because it's assurance, but I'm going to talk a little bit on the 2 points on the top. And then we have something in this simulation technology group where it is a project started in 2017. It's called Open Simulation Platform. And this is a platform which is open source and enables collaboration of digital twin simulations to solve challenges with designing, commissioning, operating, and assuring complex integrated systems. Now, what the group did, they took this project and they implemented online in a simulation transcender where you can have a secure collaborative platform for simulating complex assets. And this STC provides the OSP techniques in an easy way and secure collaboration space. So let's see how that is done. So if you're an individual having a model, you can extract this model as an FMU, is a type of simulation, a file type of a simulation model. And then what you can do is then upload that on this simulation transcender. And then you can manage access. And then different individuals can have access to that, which means they can run the simulation, but they cannot download the model. So you have the IP protected, but they can run if it's the managed access for those cert. They can configure the system and run the model. And then they can run co-simulations. And the next step of that, the trusted assurance scheme, is that you have this trust chain where you can assurance of simulation models with the trust in the models. And then you can have the simulation transcender that you can trust simulations that you're running. And then you can create a body of evidence that is part of the modular assurance. Now let's see where AI comes on all of those things. So when you run simulations, there are a lot of different parameters that you need to explore and run. And we have something called design of experiments. And with this, we can create scenarios and testing. How we do that? Imagine we have a model, a vessel here. This is a very simple model. I'm not going on what is each of these points, but I want to show you all the parameters that you can run. And you can really quickly come in conclusion that it becomes infeasible to test all possible configurations. So then what we do is we can run some initial tests and perform some evaluations of the results from these tests. And after that, we can do some adaptive testing where we let an algorithm to guide where to perform the next set of tests based on the previous tests that we have done. And this is a smart testing. And then we can have there either an AI algorithm or AI agent, which is used for adapting testing. Those can be, for instance, Bayesian optimization, Gaussian processes, genetic algorithms, and agentic AI, and so on. This is really important because these algorithms can manage the trade-off between the coverage and test objectives. For instance, to find all faults, assess the uncertainty of the risk, or find edge cases. An edge case could be like a case where two vessels, for instance, collide with each other. So I have a video here with such a case. This is running on STC. The people there have implemented this on real time also. And then you can find these test cases. So when I started, I had to learn all those things, and then I was given a project, which was to develop a simulation model of a vessel for testing autonomous navigation systems. Now, my background is in computer science. I worked a little with reinforcement learning and so on, but that was a new project for me. So what basically I had to do is we had our own vessel, and this is a vessel that we want to test. And then we usually have some simple tests. So we say, okay, go and collide with this vessel. But what we would like to do is to testing a little more complex and sophisticated things. So we want to have smart target vessels that can, for instance, perform maneuvers, crash into own vessels, or do some collision avoidance. And I wanted to implement that, train that, and upload it to this platform so I can test it. So there are two ways to go with reinforcement learning. One is online interactions, where you have the online agent and environment. I used Gymnasium for that. But also you can have an offline reinforcement learning. And there you don't have actually an environment, but you have log interactions where you can train the model with those interactions. This is research-based, so this is initial phases where you try things. So, okay, I had the environment, and then I say, okay, let's find something that I can train and is easy to train with. So I found this package which is called Derply, and this is an offline deep learning library. It's easy to use, has both offline and online algorithms, and has a very good documentation. I want to show you just a simple how you can run it. Basically, you can get your data set if you have an environment with Gymnasium or if you have all offline data. And then you can configure your model just with a line of code. And then you can just simply take that model and fit this data set if it's offline, or you can just use the environment for online. So after a few months, I did the end-to-end framework for training reinforcement learning models to FMUs, which is the file that we want to extract. So I had to have different setting environments so I can test different models. If the model was online, I had to have like an environment and setting the best performance model were then chosen to create the FMU, and then I could upload it on the STC. So that took me a few months, and by the end I had the results where I could test many models. Then I could extract it to FMU, and then here's an example of how that looked on. That was the first time we did that with a reinforcement learning model. So this is actually the model running on STC, and in the bottom you can see they try to avoid this collision, and then on the top one over there, it tries to go from A to B point. So that was about the Simulation Trust Center. Now we're going to healthcare group, and then I spent some time also there. This is also in research and development. We'll have some very good people with a lot of knowledge, so I was very happy being part of that. So what healthcare business does in DNV is basically we do product assurance, we do hospital certification and digital health in general, and DNV Healthcare Research delivers to these units and horizon scans. So there are many projects. I have 4 here, and I will focus on the left, one on the left and one on the right, which is more related to AI specifically for this talk. But I just want to go through very quickly on those. We have the Federate Health, which is a Nordic innovation. I will talk about that shortly. We have the EDITA, which is a Horizon Europe framework for digital health technologies. I have been involved with that as well. And we have XR, which is about data, and then in the end we have Cynthia, which is about develop assurance roles related to the synthetic data in healthcare. So let's start with the Federate Health. This is why we do that is because health data is difficult to share, as we all know. In particular, when it comes across borders, and this limiting the possibilities of development of clinical AI. And I have seen it also during my research. It was difficult to have good quality of data, and I was very thankful for people sharing their data with me so I could do my experiments. Here we have the people try to create a Federate Health data network for distributing training AI models for health use cases to ensure data privacy. There are 7 partners, and this runs until the end of the year. And this is a Nordic innovation project. Quite cool. Yeah. Next, we have synthetic data. When it comes to assurance, we have to think about data scarcity, which is, for instance, rare cases, like rare diseases and specific populations, for instance. And also we need to think about data privacy. For instance, access to sensitive health data. So synthetic data has been proposed as a solution to scarcity and privacy issues of health data for developing of clinical AI. So when exploring third-party assurance, we need to use synthetic data, and we need to know synthetic data quality for training data to end use. And its potential, of course, to use in developing AI-enabled medical devices. So Cynthia is an AI algorithm. The AI algorithms are very hungry. We need data. So, and the health data need to be fed to them are usually fragmented, often of poor quality and bounded by privacy concerns. Probably if some of you working with healthcare and those kind of data, you know that. You have felt it in your bones. So what this project tries to do, what Cynthia tries to do, is to develop a technical model for synthetic data generation for training AI models to be tested on a number of cases, included, for instance, lung cancer and diabetes. And this is a project that runs until 2029. And this is a Horizon project with 40 partners. I'm not part of it, but some of the colleagues I saw you before, there are. So if you're interested, you can maybe contact them to know more. And one of my colleagues that was working on that, she's doing her PhD right now. It's about synthetic data for validation of AI tools for clinical implementation. That runs until 2026. She has already a paper or framework for synthetic data quality. And there are three maybe points that I would like to specify here is, for instance, is trying to search what are the risks and how we can evaluate synthetic data quality. What are the legal implications of privacy risk in synthetic data? And lastly, how can synthetic data can be used for validation of AI? Next, we have the RMD, and then I will not go deeply on that, but the EU regulatory landscape is fast evolving, and we have the AI Act there, and the European Health Data Space and cybersecurity regulations. So healthcare follows closely the regulations and the developments and analyzing the impact and requirements on DNV and its customers. And we have also some people that they were working, DNV is a project lead for the development of AI actors and say like all the harmonized standards of risk management. And the last slide for healthcare, just want to show you other things that we're interested in there. We have assurance of AI, of course, synthetic data, cybersecurity, European health data space, natural language processes, generative AI, federated networks, AI regulatory landscape, and remote care. So this is the areas. So now the last part of my talk is where I'm right now. Right now I'm in the business area. So I moved from research and development and I moved to maritime business area. So the previous groups were relatively smaller with that. Here we are quite many. We have data scientists, software developers, and engineers. And then the group is evolving and changing very quickly. So I have few projects. There are many projects, but I try to focus on those that I knew more about and some of those I work with. So here we have AI for DATE. DATE is direct access to technical experts. And DATE provides customers direct access to 400 technical experts and has more of 70,000 questions per year. So we were thinking, okay, how we can support this process with AI. And some of the people working, I was not involved in that specific one, but some of the people there, they trained a model with 600,000 previous questions and answers to use an AI to do the questions to the right unit. And the AI also suggests relevant FAQs for the customer and case handler. This saves us around 1,000 cases per month. Lastly, also the AI generates a proposed answer for the case handler. So that's one project. Another one is about approval. So in approval, there are a lot of processes there. I will focus only in one project that has happened over there, but this involves a lot of large volumes and high complexity of deep technical competences. And you can see some numbers here. We have 200,000 incoming documents for approval per year. There are 600,000 rules, paragraphs. And there are 200 plus customers issues by the experts per year. And there are 22 technical disciplines involved in this typical project. So as you can imagine, there are some processes that we repeat a lot. Also, they are standardized and they are increasingly data-driven. So this makes those projects ideal when to use AI. So when I joined, one of my rotations was in this group. It's called Maritime, Smart Use of Data. So one of the projects that I had there is it was about proof comments. So what that means is basically when we communicate, when a document, for instance, comes to us, and then there is something missing with that document, or we want to communicate with the customer, we send the customer a message. And usually when a human writes a message, wants to do the job, sometimes it's a lot of work, so you want to finish your work. So we try to have a proof comment and utilize AI to standardize a little how we answer those responses. So this helps the users to write comments that follows DNV work process instructions. So we take these instructions and then we instruct AI to suggest changes in the comments that already the human has written. And it's quickly format comments, so they are clear, well phrased, and easy to understand. So usually it's very difficult to judge our own comments. You don't usually go to your colleague and say, can you check like this comment to the customer? Maybe you do it for some emails, but it's not something that you usually do. So it's this tool acts like a partner, so you can use it. And it's low effort, as you can see over there on the left. You have to write written already a comment, and then you will suggest you some changes. Right. And this is very important because sometimes there are a lot of messages going on for several months, and then you need to go back and check what has happened. As I said before, this does not generate comments if it's empty. It's only generated if the user has given something. And it will not invent technical details or rules. Of course, this has been tested before. It's not just things that you assume. But overall, the responsibility goes to the approval engineer, which is the person that actually clicks there. And so we don't take the responsibility of that person away. We just try to enhance his everyday life. This project has a lot of different steps. We use AI, and you can imagine we can go from a proof of concept where we can just we can try an AI and then prove it, and then we can go from proving something to something that is working in production, which is a lot of steps to go there. So we have to prove actually to the customers, to the approval engineers that this is working, so they can try, and then we get feedback from them. I will be later also there if someone wants to know more about that and what all the steps. I will be here. Now, the last project that I want to talk about is the AI for fleet recording app, and this is also a very big project. So we have the DNV surveyors are technical professionals responsible for inspecting and verifying the condition, safety, and compliance of ships, offshore structures, and industrial assets. So those people go on a vessel, and they might spend the whole day checking different parts of the vessel. So you can imagine that I have to do a lot of different things, and there might be in conditions that there is a high temperature, and a lot of different things are happening there. So how can AI help them? So we have an app, a mobile app, that they're used to report if they find something. So they can go on a vessel and say, okay, this has a problem, so they will take a picture of that, and later on they will report that. And they need to know, for each of those objects, they need to know the number that represents. And there are a lot of, I promise you, there are a lot of objects on a vessel. So basically, we have implemented AI, image recognitions, on this app, and this suggests which of this object that the user is taken, the surveyor is taken, is represent, and they can simply just choose it. You can see it on the right side, and they can report it immediately. This is also offline. Here I want to mention that this can sound like also a very simple project, but imagine that you need to consider that they need to work offline. They need to have a model that is light. Also, it needs to be useful to give them always what they need to give. So, and these people are very difficult customers in the sense they have needs. So we need to make sure that they take back what they need. So these models are trained with previous images representing different reporting levels. Let's, for instance, a lifeboat. And this improves the surveyor's workflow in general. Now, I just want to say a few words about this project. I had it was quite interesting with me when I went there. This project was already running. So there was already ML team, and I had to learn everything and then contribute all that. And one thing that I really enjoyed was actually talking, because we are the ML engineers, and then we have the developers that they're running these models, and we have also the software engineers, and we have to collaborate, talk, and have discussions with them so we can put this in the pipeline in the production. So if you want to know more, I will be happy to get some questions, so discuss it later. I'll be around the cafeteria. And with that, I would like to thank you very much for your attention. And thanks again, the Stavanger AI lab, for inviting me here. It was a pleasure. Thank you very much.